Have you ever wondered how electronic components can maintain a constant current even in face of external factors? That's where the current mirror comes in. This simple component has a lot of applications, and in this video I'm going to explain you in 3 steps how it's working. So at first I'm going to explain you how the current mirror works with an NPN example. Then I show you a PNP current mirror. And at the end, this is really important, I give you the factors how you can make it work in your application and not just on a theory side based on some calculations. So that's important to know. Go for the video. A current mirror, for this we just take at the beginning a stabilized current or a stabilized voltage which you can get out of your microcontroller, like your GPIO voltage or whatever. And there you just connect some kind of resistor. With this resistor you can define the current which is flowing. And what we connect as next is some transistor. We choose in this example an NPN transistor, and what we do is that we directly connect the base with the collector of the transistor. So what is happening now? This is just looking like some kind of diode, so you can more or less easily calculate still the current you need here. But what is happening inside of the transistor is that we have some split of the currents we have. So one is going inside of the base and the other one is going through the collector and going directly to the emitter. So when we calculate that one, that by the way is the same I1 like on top. So if we want to calculate that, we have I1 is equivalent to the sum of AC plus IB. And this one here we can calculate as IC is equivalent to IB multiplied by the current amplification of this transistor. So, okay, now we still have the same current, we still can calculate it. Let's connect another transistor here. And now we also do it like this and connect that one to the base, to the ground. So what is happening now? When we think about our diode we have here, we know that a diode is behaving like this. So we have here our voltage and we have some current, and if we want some current to go through the circuit, we have to bring some voltage drop over the diode, and this is typically something around 0.7 volt. So this is what we have here, and the same what we have here in this case or in this area. So what's happening now if I increase the current? The voltage is slightly changing, so in that case it's not so beautiful, but you have here some kind of voltage change. And this voltage change is giving you here a change to the potential of the ground. So it's not just shifting that voltage, it's also shifting the voltage here because both are in parallel. So what is happening now, if I have here the same current flowing because I have the same semiconductor, I just get the same equation like here. So what's happening now is that I also can say, let's call that one I2, or yeah, we do it like this, we call it I2, and I2 is equivalent to the base current multiplied by the current amplification like we have it here. And also for sure it's just the normal base current. So what I have now is that I have something which is able to drive me resistance or to drive me some current through that part. What I just need to do now is to connect that one to the sensor or whatever I want to use, and just bring it to the unstabilized voltage. I think I wrote 6 to 18 volt. And now I have here a defined current which is not depending anymore on the supply voltage. And this is really great if you have some stabilized sensor, or if you need a stabilized sensor. This is helping you a lot. Before I give you some hints of the schematic, I would be glad if you give me a thumb up that I can do more videos like this and the channel can grow. So let's go back to the electronics. So what we have to consider now that it's working, so we have here a current amplification and we have here a current amplification. What we need to ensure is that both are equal. And the way we do this is there are several ways of quality we can use. So one way is that we just pick out one of the same box, but I don't like this. The reason is that we have here most times another voltage drop for the collector emitter and compared to that one here. The reason is easy. I have here a voltage between 6 and 18 volt, and I have here maybe some drop that it's working. I just need at least a drop over a resistor of 5 volt, so that giving me a drop range of 1 to 13 volt. And here in that case I just I can define it to 1 volt or whatever. So this gives me a lot bigger power dissipation on that part of the circuit and compared to that part of the circuit. So this is meaning that that one is heating up, and when you have a look inside of the datasheet, you always will figure out that you have more than one slopes of this. So you have something like this, and they are normally numbered out. And the reason why you have this is that one is normally based for 125 degree, and number 2 is typically 25 degree, and the other one is typically minus 40 degree. So what's happening now, if one is heating up and the other one not, is that we have a difference inside of the voltage correlation to the current we have. So in other words, it gives us another different current amplification, and this is what we don't want. So we can prepare, or we can be prepared in the case if we just go for choosing a right housing for our transistors. I just would recommend you to buy some of those kind of resistors. This is the quality number 2. Or if you just know before that you want to build a current mirror, and then I would highly recommend you to buy some matched pairs of transistors. They are slightly more expensive, but they are stabilized for that what we want to do. They are specially built for that kind of application, so they are exactly built for current mirrors. So this is what I would recommend if you want to build it up. Just as an other hint, you also could do the same if you just want to go for PNP transistors. So the way this works is just that you have your voltage supply here, and then you just go inside of your PNP and you just do the same here. That one is grounded, and sorry, small mistake, that one needs to be here. So, and then you can go out here and come back here, make the same again, and here you can connect whatever you like don't know, 6 to 18 volt. It's just the same, but it's the same issue with the temperature. Be sure that you have the same housing at least. Otherwise, you can run into a thermal issue, and if you have the thermal issue, that whole thing doesn't work like you expected. You get some different currents, and this is not what you want. So, thank you for watching. I hope you learned something. If you like to see more of this, here are some other videos. I would be glad to see you again. So, see you next time.